What's up, you data friends? It's Yanis here and welcome to my channel. Now please note that this video is actually video part 3 of the unsupervised machine learning series. In this series, very quickly we go through how to take some raw data from Excel, put it into a database, send that data into Python, then in Python clean the data, run Kmeans, then run PCA, run some other ways of improving your clusters, and then save that cluster's results back to the database, and then connect the database with Power BI, which is where we're going to build this automated, nice, clean dashboard in order to analyze our clusters and investigate the traits of each cluster, create insights, and then how we share those insights back to the business, which is exactly what a good data scientist does. It translates raw data into valuable and actionable insights. I'm going to have the links of the previous videos in the description, so you should go on and watch them before you watch this video. And the last thing I want to say is that if you're new to my channel and you're passionate about data science, I would really appreciate it if you click the like button, subscribe to my channel, and enable notifications for my future videos. Right, starting from where we left it in the previous video, what we want to do now is to find a way to further improve our results. And one way of doing this is to combine our variables, try and find different combinations of our variables that actually make sense. And the way I've done this is by actually going back to video part 1, where we investigated our variables, where we've done the exploratory data analysis, and try and see if we have similar groups of data. For example, if we scroll down to the questions that are not about the background and it's about the behavior of the individual, for the first question we see, which is, let's say this one, how often do you attend entertaining events in a year? So what we see here, let me just make this a bit bigger so it's better to see, is that we have a very strong group of people attending events 4 times a year, a very strong group of people 3 times a year, and then for 1, 2, and 5 plus, we have very small groups. So what we can do is to combine data together. A combination that makes sense to me is to combine 1 and 2 together, since they are very close to each other and they don't have enough samples in them. And at the same time, combine 4 and 5 plus times a year together too. So if you were to interpret this, you would say that you have the people that go once or twice a year, people that go 3 times a year, and then people that go a lot of times, which is 4 or 5 times plus a year. In order to do this in the code now, we want to go back down to the code and create a new variable or a new column. And this column, we're going to name it 1 or 2 times a year. And then what I'm saying is that, let me add space here so you can see all of it, is that if the how often you attend entertaining events in 1 year is like 1 times a year equals 1, or if the 2 times a year equals 1, then I want you to set this variable equals 1. Then I want to repeat the same process for 4 and 5 times a year. So again, I create a new empty column. I set the column to 0 and I name it 4 or 5 times. And I'm saying exactly the same thing. If the 4 times a year equals 1, or, which is the or over here, if the 5 plus times a year equals 1, then set this new column as 1. So now I have created 2 new columns which are going to replace 1, 2, 3, 4 columns that we had before. So now I want to repeat this process and this methodology for every other variable that we have. So we go back at the top, we investigate the count plots, we see if there is an appropriate combination that we could possibly do, if it makes sense. And then we come down to the code and we apply the same thing. So in our case, I'm going to quickly show you the ones I've done, and you can actually open this code through my GitHub repository and actually see the ones I have done, because this is not fully visible. I have to put everything down. So for the social media, I have actually combined the Have a Day Plus more than half a day, which makes sense. Is like the people who are on social media a lot of time, more than half a day. For the how many hours are you willing to travel, I have combined 1 to 2, 3 to 4, and 5 to 6. For the do you enjoy adrenaline rush, I have combined the mostly and somewhat agree together, and I have also combined the mostly and somewhat disagree together. As you can see, my combinations make sense. I'm not combining mostly agree with mostly disagree, which are two completely different things. They actually have to be close to each other or make sense to combine those two things together. Additionally, I have more combinations down here. Are food areas, coffee areas, bars, toilets important to you? I have combined again mostly and somewhat agree, and mostly and somewhat and entirely disagree all together. Here I have combined the entirely, mostly, somewhat, and neither disagree all in one go. Here I have combined mostly, somewhat, and neither unlikely, again, 3 of them in one go. And down here I have combined mostly and somewhat disagree. So again, you can go in my GitHub repository and see all my combinations down there, or you can go at the top and investigate yourself the count plots and apply different combinations if you find them appropriate. Then what I did is that I have this replace here because one of the questions had the apostrophe. So I'm just replacing it to be empty space. And what I do now, because I have all of these new columns, let me see, I think all of these ones are the columns we have just created, which are combinations. What I have to do is that I have to exclude any columns that they combine together. For example, this first one here now, 1 or 2 times, is combining these two together. So what I did, I put hashtag in front of it, and with this way, I'm not going to have this column now in my dataset. Same way with 2, same way. You see how I left 3 because I haven't combined 3, and then I removed 4 and 5 plus. So I did the same for any of the columns that I have combined together, and I saved all this column into a new list, which is going to be the list with my new features. The next step I did is to run Kmeans now on this new list, right? On these new features, this new dataset. So the first thing we do is that we select only the new features from our data frame and then the dot values. So we actually get the numbers and we save them into xtrain. Remember now, this xtrain doesn't have any PCA on it. This is the original data set. Then what I do is that I'm doing a range of clusters again. I want to check from 2 to 20, and then I run my Kmeans for each cluster from all the way from 2 to 20, and then I plot the inertia down here. We have explained all this code in part 1 video. And what we see now, if we compare the results with part 1, we can see that for 2 clusters, we get less inertia with these Kmeans. For 2 clusters, for 3 clusters, for 4, 5, for all of them basically, we get less inertia. Which means that without even running PCA, we've managed to improve our results by minimizing the within cluster square. Additionally, if we compare these results with the results we got when we ran PCA and then Kmeans, which is this one's down here, let's test this one. So we scroll down, then we compare them. We can see that we still have better results with this approach versus the PCA approach. It's very close now, but it's still less. So the next step we want to do now is to apply this method first, then run PCA, and then check the results at that time. So maybe we can use both approaches to improve our K-means results. Another thing to note here is that in our inertia plot is a bit more visually clear that we should go with 5 clusters, as is a bit more steep from 4 to 5 and a lot less from 5 to 6. Right, going to the code now, and we have explained all this code in the previous videos. First, I ran a K-means clustering with 5 clusters, and then I ran PCA with 2 components to be able to visualize the data. And then this bit here is where we plot the data down here. And as you would notice, there is a lot of changes down here versus what we had before. So if we quickly snip our results before, so if I go up here and then I snip this, and then we compare it with the new cluster, here we go. So the first thing we're going to notice is that the explained variance of the first two components now has actually went up in this new Kmeans model. So now we explain about 28% of the data of the variance with the first two components versus the sum of these two, which is about 24% of the data. Additionally, what we see in the actual visual is that in the new data model, these two clusters were different clusters before. However, now we've managed to push them together after running PCA and also combining the variables. Additionally, we can see that this cluster, I think, stayed the same. This cluster at the top stayed the same, but it's a lot more compact right now. And in the middle, we actually have two big clusters now with similar behaviors. And the fact that we have two big clusters on top of each other does not mean it's a bad model. This is again because we are only explaining 28% of our data and not the full or 95% of our data. Moving on now, the next step is to identify the optimal number of principal components using this new dataset with the combined columns that we have just created. And again, if you want to understand this code, we have explained all of this code in the previous video, so you should try and go and watch that. So after we run this, we get again these results, which we need to compare now with the previous results of PCA. So these are actually the previous results. So if we put them next to each other, what we can see is that the total variance of the dataset has actually dropped in this new dataset, and the 95% variance now is at 8.8 versus 9.2 we had before. And in order to hit this 8.8 now, we only need 36 eigenvectors or principal components versus 53 that we had before. So now, with a lot less variables, we can actually hit 95% variance. The next step now is to run PCA with 36 eigenvectors and then take the output and feed it into Kmeans to see if A, we can improve the results, or B, we need to change the number of clusters. So to do this, again, I am running PCA with 36 eigenvectors. Then I am running Kmeans and I'm plotting the inertia down here. Again, this code is copy and paste from before. So if you don't know what it means, then you should watch the previous videos to understand how it's done. And what we see now is that we actually have to go and copy and paste the previous results. I'm going to copy these ones, which are beating both the previous PCA and the initial results where we had before. So if I come down here, then I put them next to each other, what we can see straight away is that we've managed to minimize inertia even more now. And again, I think 5 clusters, if we check the actual plot, is a lot visually clearer now that all we need is 5 clusters for this dataset. Moving on, the final step now is to run PCA with 36 components and then run Kmeans with 5 clusters. So what I do is that I run my PCA, I create my dataset, and then I feed this dataset into Kmeans with 5 clusters. Then I go, I save my Kmeans.clusters, which is the cluster between 0 to 4 into clusters. And then I create a new column in that initial dataset that we had called SQL_query, the dataset that has all the data without excluding anything. And then I pass the clusters back into this dataset. So this is the dataset. And then if we scroll at the end, we can see we have clusters here with the number of cluster. And then I have also created a new column, which is called cluster category, where I have actually renamed the clusters. I have given them names. So cluster 1, cluster 2, 3, 4, and 5. Additionally, I have also done one last thing that is actually going to help me order the columns when we visualize them, is that I have created order columns for the string or character variables that I cannot order from 1 to something, that are not numbers basically. So what I'm doing here is that I'm creating a household income order. I start with 0 and I say if it's less than 20, 1, if it's 20 to 34, 2, 3, 4, 5. And the reason I do this, again, is so when I visualize them later on in Power BI, I can actually use this column to order them in an order that makes sense, not having 200, then 20, then 75, then 50, etc., etc. Then I do the same for social media, as you can see down here. I do the same for this column, for this column, for this column, and for this column, and for this column. Again, you can actually copy and paste this from my GitHub repository or just download and use this code. Right, the final step now is to export the data, and I'm going to show two ways of exporting the data. First is going to be in the database, in an SQL database if you actually have one, and the second one is going to export the data using a CSV. So to export the data in an SQL database, what you need is to go and watch my video part 1 where I have explained how to import the data from a database, and we're going to use the same settings now. So what we need to do is that I'm going to put this next to each other. So first we want to import SQL Academy and import create engine. And then we also need to import this URL library. Then we need to set the coded now, and then you can literally copy and paste exactly what I have here. Then in the server, you need to put the same server as we have in video part 1. In the database, the same database. And again, we need the trusted connection. The next thing you need to do is to set this engine to be equals create engine and literally copy and paste exactly what I have over here. And the last thing you need to do is to say SQL underscore query to SQL. Then you need to put the name of the table, the schema, use the same schema, or if you want to put a different one, you can use a different one. Then con, which is a connection, is going to be this engine over here. And then if that table exists, what I'm saying here is that I'm saying to it, every time I run this, I want you to replace that table if it exists. So it's going to delete it, drop it, and create a new one. And this SQL query is actually our raw data, which is the output that we have just created above here. So if we visualize it, it's actually this one. So we have all the data, and then we have our clusters, and then we have our order columns. And if you want to export the data in a CSV, all you have to do is put the name of the data frame, so SQL underscore query, then dot to CSV, and then the name of the CSV, and then the separator. And this is actually going to export the file in a CSV file in your current working directory. I will also have the CSV file with the output in my GitHub repository in case you want to download it from there. So now, if we head over into our SQL database and we refresh the tables, then we're going to see that we have a new table, and this new table is going to call events cluster output, which is the table we have just created in our Python, and we saved it back into the database. So if we try and run everything from that table now, we can see that it's our output, and then we can see we have our clusters again, and we have our orders columns. Additionally, what I like to do is that before I connect this table with any front-end visualization, I actually want to create a view out of this table, just in case I want to join in the future other data from other tables. But if I connect the table with Power BI, I won't be in a position to do that. But if I say create view, and then I name the view as the one I have just created. So let me show you quickly, copy this, paste, and then as, so this name can be any name. And then if I run this, it's actually going to create a view, which is right here. So then I can connect this view with Power BI. And in case I want to join additional things on this view, I can just edit the view. So Alt 2. So here is where I can edit the view. I can say left join and start joining additional data from my database. Right, the next step now is to send this data, which is the output of Python, into Power BI and start creating this dashboard in order to analyze all of our clusters and create valuable and actionable insights for the business. However, I'm going to stop this video here and finish the dashboard in the next video. So I hope you enjoyed this video and you've gained enough value out of this video. And if you feel like you did, please click the like button, subscribe to my channel and enable notifications. If you have any questions, please let me know in the comments below. Otherwise, thank you very much for watching this video and I'm going to see you in the next video.